So this is me and Ava's linear versus exponential slideshow.
This is our linear growth. The pig population of a small farm increases by 200 pigs a year. What will the population be in 7 years? And when will the population be over 800 pigs? So this is our equation, and you plug 200 in for m, and then you keep x, and then b is plus 100. Y equals pigs, m equals slope, x equals years, and b equals the start. So our next equals now is, our now equals next is next equals now plus 200, and our start is 100. Our population in 7 years is y equals 200x plus 100. So for x, you plug in 7 to find how many years it's going to be. So 200 times 7 plus 100 is equal to 1,500. Our population will be 1,500 pigs in 7 years.
Stop talking, it's work.
When will the population be over 800 pigs? Since 3 is 700, it's not over 800 yet, and since 4 is 900, it's the 4th year. It's going to be over 800 pigs.
Okay, so for the linear decay, the question is, a wolf population at Yellowstone National Park is decreasing at a constant rate of 2 wolves every month. How many wolves will there be after 7 years if the current population is 347 wolves? And when will there be 59 wolves left? So since it's a linear function, the equation is going to be y equals mx plus b, and y equals the number of wolves, m equals the slope, and x equals the time, and b is the initial value. So our equation now would be y equals negative 2x plus 347. And our next now equation is next equals now minus 2. And the start is 347 wolves.
Dude, I think my lettuce problem.
Okay, so solving the previous question, the wolf population in 7 years will be 179 wolves. For the equation, since x is going to be per month, you have to multiply however many years there are by 12 because it is 12 months. So 7 times 12 equals 84. So your equation is going to be y equals negative 2 times 84 plus 347, and that equals 179 wolves. And then the next problem is, what year will there be 59 wolves? Okay, so you're still using the same formula, and so you're going to plug in 59 for y, and solving that, it's going to be the 12th year.
This is our exponential growth equation. So Tina has $50 in a savings account. The interest rate is 10% compounded annually. How much will she have in 2 years, and when will she have over $100? So our explicit equation is a times 1 plus r over n and n times t. So a is our initial cost, 1 is representing keeping 100% of our ratio, r is our ratio, n is our number compounded, and t is our time. So our new equation is y equals 50 times 1 plus 0.1 over 1 and then x. Our next equals now equation is next equals now times 0.1, and our start is 50. So now, how much will she have in 2 years? Our equation stays the same, but our x changes to 2 times 1, and the answer is $60.50. When will her savings account have over $100? So this is our equation, and
You're going to use the guess and check method. And so if you find for 7 years, it's going to be $97.44, and then for 8 years, it's going to be $107.18. And since you're trying to find when her savings account will be over $100, the better answer would be 8 years, since it's over $100. And then for the exponential decay question, the question is the value of a house decreases at a rate of 8.3% annually. The house on Drury Lane is currently priced at $704,569. How much will the house be worth in 24 years? And when will the house have a value less than $100,000? So our equation, since it's an exponential function, is going to be y equals a times 1 minus b to the x power. Y equals the value of the house, a equals initial value, b equals the decay rate, and x equals time. So plugging all of that in, your equation is going to be y equals 704,569 times 1 minus 0.083 to the x power. And our next now equation is next equals now times 0.083, and your start is going to be 704,569. And since 8.3%, you're going to have to convert that to a decimal for the equation. It's going to be 0.083 because the decimal is going to be moved 2 times to the left since the percent value is being multiplied by 100. But yeah. And so, answering the question previously, the value of the house in 24 years is going to be $88,061.81. And using the same exact equation and plugging everything in, so that means plugging in 24 for x, you're going to get that answer. And then for the next question, it's going to be, when will the house be worth less than $100,000? So you're going to use the guess and check method again. And so if you find on the 22nd year, it's going to be $104,724.65. And then for the 23rd year, it's going to be $96,032.50. So since you're trying to find when will the value of the house be less than $100,000, it's going to be on the 23rd year.